Hi, I'm Dan, and I'll be taking you on a tour of our work on inferring network effects from observational data. Suppose you're interested in a network of subjects, such as users of a website, and each of these subjects has some property you wish to affect, such as the time users spend on site. This is called the outcome. Imagine that each user can be assigned to a treatment group or a control group, and users in treatment have a new feature enabled that users in control do not receive. How can we determine whether treatment leads to improved outcomes? This analysis is complicated by the fact that each individual can statistically depend on connected individuals, but recent work in experimental design has shown that methods which randomize at the level of graph clusters rather than individuals can work well. First, treatment is assigned by a graph cluster, then outcomes are measured. This approach is useful when treatment can be ethically and efficiently manipulated, but we sought to identify whether reliable causal effects can be obtained without experimentation. Observational data is complicated but plentiful, and subjects can select whether to adopt the treatment, and this choice can depend on the broader network context of a subject. Our approach begins by constructing a templated representation of a network. This representation contains the intrinsic attributes of a node, such as the ages of each user, the intrinsic treatment of that node, multisets representing the attributes of neighboring nodes, and multisets representing the treatments of neighboring nodes. We use a relational causal diagram, provided as background knowledge, to represent dependencies between these multisets. And from this diagram we can derive an adjustment set, which is a set of variables that must be corrected for in order to recover the direct effect of treatment on outcome. We can safely ignore any characteristics that don't appear in this adjustment set, and that leads to an efficient estimator of the average causal effect. This estimator can be used to infer a wide variety of causal effects, including neighborhood treatment, insulated individual effects, and an array of peer effects. We found that the performance of this approach is nearly as strong as that of a well-designed experiment, and we hope that the broader applicability of observational causal analysis will enable a variety of causal studies on networks that wouldn't be feasible with experimentation. Thank you, and hope to see you at our talk.